Oh, we're on the right ones. Okay. So back to our learning goal, which is I can solve proportions. Well, what is a proportion then, first of all? A proportion is a statement that two ratios, I need a pen here, that two ratios are equal. Okay? Two ratios are equal. I'm going to have to take a moment and do some calibrating. For some reason, I got thrown off. So what's a ratio? We've already talked about that. What's a ratio? If we are going to understand a proportion that says a statement that two ratios are equal, we got to first understand then what's a ratio, because that's part of our definition. So what's a ratio? Just a ratio. Go ahead, look it up somewhere and find it. What's a ratio? A what? It's a problem, yeah, it is a problem. I'll give you that. Or it can be part of a problem anyway. I bet some of those notes that Rob set of notes I just had open, that first set of notes we took in 1.8, I bet they'd be useful. Since that one's titled with rates and ratios and rates.
A comparison of two quantities by division.
No, a comparison of two quantities by division. And typically they're written how? Anybody remember that part? When we're comparing those two numbers, and it's by division, how do we typically write them?
Decimals.
Not as decimals. Typically we don't actually divide them out. Typically we leave them like they are, unless we're changing them into a rate. If we're turning them into a rate, then we divide them out. But if we want to keep them just as a ratio, how do we typically see that written? If I'm comparing, remember, the number of boys to the number of girls in this class, what were we doing? We put the number of boys upstairs in a fraction and the number of girls downstairs in a fraction. So typically we write a ratio as a fraction. So if we're comparing two numbers by division, we're writing it as a fraction. Well then now when we have a proportion, we're saying we have one fraction, one ratio equal to another fraction, another ratio. They are really the same thing. And we already talked about that. And I believe we said if we have 6 boys in here to 3 girls, we could write that as the fraction 6 over 3, right? Did you not say that? But 6 over 3 is also the same as what other fraction? How can we also compare that? No, we can't say it, then we'd be comparing girls to boys. I want to keep the comparison the same. I want boys to girls. If 6 boys to 3 girls is one way of us, let me show you it. If 6 boys to 3 girls is one way to write the ratio, the fraction, what's another way I could write that same fraction that would still really mean the same thing? So for every 6 boys, there are 3 girls. 2 over, for every 2 boys, there are, I'm going to call them B's because I run out of room there. For every 2 boys, there's 1 girl. So those mean the same thing. We can set them equal to each other, can't we? 6 over 3 is the same as 2 over 1. They both mean the same thing. So now we have a proportion. When we said a fraction equals another fraction, we have a proportion. Okay? And what happens in a proportion model, there's this little thing that happens that says if you can't figure out what that missing number is, you can use this thing called a cross products property. If you have the fraction a over b, and it is the same as, it is equal to the fraction c over d. So in this case, let me just kind of clarify for you what that means. A would be the 6 boys in the first fraction. B would be the 3 girls in the first fraction. C would be the 2 boys in the first fraction. And D would be the 1 girl in that, our second fraction, I mean. Okay, so they're just using abstract, saying A is the first numerator, B is the denominator that goes with it in that comparison. C is the other numerator, the second numerator, and D is the denominator that goes with that one. That's all that is really saying. They're really saying that the cross products property, I mean, says if you have a fraction equal to another fraction, if you take A times D, if you multiply the numerator of the one times the denominator of the other, it should be the same as the B times C. The denominator downstairs in the first one times that numerator that's upstairs in the other one. Is it cross products property we can count on that will always hold true. Let's see if it does in our proportion that we set up here. If I took 6 times 1, remember this is like our A right here. This is our A, this is our B, this is our C, this is our D. If I took A times D, 6 times 1, what is that? What's 6 times 1? 6. And if I took B times C, 3 times 2, what's 3 times 2? 6. So we end up with 6 equals 6. That's true, right? That is a true statement. So we can count on that always holding true. So since that always holds true, that's one way to solve proportions. Okay, anybody think they know what the answer might be to number 1 without us really doing any work right now? Think they know what would be the same as 5 halves? Any ideas? Or maybe we could think of it like this. 5 chairs for every 2 tables is the same as how many chairs for 8 tables? 2.5? Okay, first of all, let's think about this. If the numerator in this one is bigger than the denominator, what better hold true for that x?
A bigger number.
It better be bigger than what?
10/8.
It better be bigger than what, first of all?
5.
If this 5 is bigger than this 2, this better be bigger than the 8. Okay, it better be bigger than 8. So we can throw 2.5 out right away, can't we? Because 2.5 is not bigger than 8. So I'm thinking that doesn't even seem reasonable. So instead I have to say, okay, what I gotta have a number bigger than 8 at least. So no way, okay, then let's use the cross products. If we can't figure it out without, then we'll use our cross products. In the cross products, it says you're gonna take that numerator, that 5, and you're gonna multiply it times that other, this is what they mean by cross. They're diagonally across from each other. So 5 is gonna get multiplied times the 8. That should be the same as, if you set up the multiplication problem, 2 times the x. That will help us solve for what x should be. So we set up what are called cross products. What's 5 times 8? 40. 2 times x? 2x. Now we're back to what we did back in lesson 1.3.
5 by 2.
Yeah, now we're solving a one-step equation that has multiplication in it. And to undo multiplication, we divide. So we're going to divide both sides by what x is being multiplied by, which is 2. So I'm going to divide both sides by 2. And 40 divided by 2 is?
20.
40. Anybody have that answer in their head, but they just didn't want to give it out? They thought, I know what it is. It's 20. Did you know that, Preston? Yeah. How'd you get that in the beginning without us doing all this work?
Well, like, when it's like 5 times 8 and 2 times x, I thought, like, with 20 plus 20 equals, like, 40, and, like, 8 times 5 is 40, so.
Okay, so that's though after we had already set up the cross products, right, Preston?
Yeah.
Yeah, okay. I want to know from someone, did anybody know, before we did any of this, did you have another way to figure out that this was 20? Anybody have another way that said, you know what, I did not need to do all this. I had a different way that I knew that answer was 20. Anybody have to know? No? Okay. Let me just show you a little trick. I don't want you even necessarily writing this down right now. I want to show you a little trick that sometimes we could use this instead. 2 times what is 8? 2 times what is 8? 4. If you have to do that to the downstairs, you also do it to the
Oh yeah, 5 times 4.
Yeah, remember renaming fractions to get common denominators? We multiply the upstairs and the downstairs by the same thing. What is 5 times 4? 20. Look at there, wasn't that pretty slick? And that one, that would actually be a quicker, shorter way to go about it. But not all of them are that friendly. Like, how about the next one? Do you think that one's as friendly? Do you think we could rename? We You know? Okay, let's try our cross products then. Let's do that instead. Okay, what would the cross products look like in this one? Somebody tell me what the first multiplication would be.
-3 times 4.
-3 times 4. These two would get multiplied times each other. Then we set our equal sign up. We say that should be the same as, what would our other multiplication problem be? A times 1, okay? So our other cross product is A times 1. Okay, now we're going to try and work with our outer calculator as much as we can, okay? What's a -3 times 4?
-12.
-12. A negative times a positive is a negative, and 3 times 4 is 12. What's 1 times A? 1A. Okay, what would be our last step then?
Divide 1.
Divide both sides by 1, yeah. -12 will get divided by 1. 1A will get divided by 1. These guys will cancel. What is -12 divided by 1? -12. Yeah, so does dividing by 1 really change anything? Ever? So when there's a 1 in front of the A, could we really just kind of like ditch it and say it's just A? Yeah, just like we can put a 1 in there when there's nothing there, we can take a 1 out of there. But it has to be a positive 1 to do that. Okay. Let's just explore this a little bit and see if we could have done that other method in this one. Well, we're looking for A, so it wouldn't do us very much. It wouldn't help us very much to try and do something to 4 to get A, would it? How about to the numerator then instead? What could we do to 1 to get -3? Times it by -3. If we times this 1 by -3, then we would have to do it to the downstairs, so we would take the 4 times -3. What is a -3 times 4?
-12.
-12. Wow, look at that. It works, doesn't it? Okay. So again, sometimes it's we can just do it that way. Okay? And actually, you know, that's kind of what we ended up doing here anyway. We took the -3 times the 4. Anybody have any questions on either of those before we try the next one? Okay. Why don't you go ahead and try the next one, see what happens. Do it your way, figure it out. What are you going to do to get the answer for this one? Is that?
H equals -4.5.
Oh, Adam thinks it's -4.5. Okay, we'll see what anybody else gets then.
What's the first step? Follow your arrows here and then so go ahead and do your arrows.
You got me convinced.
Okay, so that's your first one.
You want to go and do it at the board end?
-6
Yep, show her exactly what you did there.
to 2.
Times 3 equals what? What's your first one here? We're just on this side now. So 1 times what? Okay, so
What's the difference?
we did 5 times A base of H.
H's.
And then you look at the next one, 2 times X, and let's go back.
I'm saying, I don't know. Negative times positive. So like, if it's a negative times a positive, do you just add
If it's a negative times.
Okay, first of all, we use cross products. Is that the right setup? Did I set the cross products up correctly? -6 times 3 on one side,
6 times 3.
and 1 times 4H on the other.
18.
Negative 18.
Okay, what is -6 times 3?
So put -18.
-18. And what is 1 times 4H? 4H. Okay. Now what do we do?
Divide the 4.
Gonna divide both sides by 4. What's a negative divided by a positive? Negative. Does 4 go into 18 a whole number of times?
No.
Okay, how many times does it go in?
4.
4, with how much left over? 2, which is 2/4, which is a half. So if we were gonna do this really without a calculator, I would venture to guess, here's what should happen first, -4 2/4, which then can be renamed as -4 1/2. Which those of us who use the calculator probably got negative what? 4.5. Are they all the same thing? Do all of these mean the same thing? So, again, we're trying as much as we can to work without that calculator, because if I say you can't use it, you don't want to be dependent upon it. And so, using cross products, we should end up with a -4 1/2. Was this one of those that we could have done this? Said, what times 1 gives you 3? What times 1 gives you 3? 3. So then we'd have to go upstairs and do the same thing. But notice what's going to happen this time. We're going to have -6 times 3, which is what? What is -6 times 3 over here? -18. So in reality, there that is right there, isn't it? -18. So we really did that. And we took -6 times 3. And then on the other side, we end up with 4/8. So we end up really with the same stuff that happens when we do our cross products. Okay, so the final answer is either given as the mixed number -4 1/2 or as the mixed number, or not mixed number, decimal answer -4.5. Okay. You know, I look at this one up here, and this is definitely one of those that I just want to start and say, is there anything, does anybody happen to know what you take 2 times to get 2 1/2? Anybody just happen to know what you take 2 times to get 2 1/2?
1.5.
1.5? 2 times 1.5 is 3. Take, what do you have to, like, remember when I'm trying to use this rename the fraction thing like I'm doing over here, I took 1 times 3 to get 3. What can I take times 2? That'll get me 2 1/2. Not as easy, is it?
0.5.
0.5? No, that would actually be 2. See, it's not as easy. So you know what? This is one of those that I'm sure happy they have those cross products for us to do, because it's not as easy to be able to figure out what times 2 is 2.5. So what would our first multiplication be in the cross products? Talia? Nope, Talia. What would my first multiplication be in this one? 2 times 15. Okay, thank you. And Andrea, what would be my other multiplication? X times 2.5, yeah. Okay. Blake, what is 2 times 15? 30. Samuel, what is X times 2.5? Yeah, 2.5x. Seth, what would be our next move? Divide both sides by 2.5. So 30 is going to get divided by 2.5. And 2.5x is going to get divided by 2.5. Oh, I know, you're going to those calculators so quickly, I want to treat this like money. 2.5 is like how much money? What's 2.5 in money? $2.50. Okay. We have to take $2.50 into $30. Let's take that $30 and put it into more reasonable amounts, like what? This, we make it into $5 bills or $10 bills? What can we do with that $30? Come on, I want you to be able to process without a calculator. What can we do with that $30? Is that, how many $10 bills is that? 3. Okay, so maybe we could just figure out how many $2.50 there are in one $10 bill. Maybe not, okay. There's 4 $2.50 in $10. Seth, can you convince them why? Okay, there's 2 $2.50 as you can take out of a $5 bill. And there's 2 $5 bills and a $10 bill. So now we've got 4 times you can take $2.50 out of $10. But how many $10 do we have in 30?
3.
3. So what do we have to do with that 3 in this form?
4.
Multiplying. 3 times 4 is
12.
12. For those of you who already went crazy and went to your calculator, did the calculator agree with us? Yeah, it is 12, isn't it? So figure out a way you can process these things, though, you guys, without a calculator. And money's a really good way to do it because either you're going to be a spender of money or a maker of money, or you're going to be working in the retail business where you have to give people, you have to work with money and you have to give people back money in. You know, there's nothing worse than when somebody, you know, you're working in retail and they look at you, you look confused about what you should be doing. They want you to look confident when you know what you're doing, when you do know what you're doing, okay? So, anybody have any questions about solving proportions, the part that we went through here today? Anything we should clear up for you? Okay. Then we shall, I don't know why sometimes I might turn off that, you know, like sometimes it just doesn't show up, I don't know what that is. You go ahead and get out a sheet of loose leaf paper then, to get started on homework.
No, what about the back?
We're gonna do that tomorrow, Adam.
Oh,
Carefully write down what the assignment is you have to do because you're doing the evens in 2 different groups. You're gonna skip over some problems. You're gonna start at number 10 and do evens through 18. That should be 5 problems. And then you're gonna jump ahead to number 26 and do 36 evens, and that should be another 6 problems. So altogether, when you're done, you should have 11 problems of homework completed. So your name starts out your heading, assignment number, page number, problem numbers, and then you can get going on your homework.
You just have to check that.
He has to correct it,